Hey gang, today we're going to continue looking at arithmetic and geometric sequences. Last week we practiced with arithmetic and geometric sequences separately. Today we're going to put them together so you make sure that you can recognize both as being separate things and understand how to use the recursive and explicit formulas. Okay, so here are some recursive formulas. Remember, a recursive formula generates the sequence. It gives you the first and tells you what to do to the first to get the next, and to that to get to the next, and that to get to the next, and so on. So we're going to generate the first 5 terms and then write an explicit formula that represents the same sequence. I think on your notes, your original term might be labeled A of 1. Change that to A of n as we're working as seen in the video. All right, so first one we have A of n equals A of n minus 1, which is telling us the previous term, plus 12, which means this is arithmetic because it's an adding sequence. And it tells us that the first term is 19. So starting with the first term being 19, we need to add 12 repetitively to get the next couple terms. So the second term would be 12 more than 19, which is 31. The third term would be 12 more than 31, which is 43. The fourth term would be 12 more than 43, which is 55. And the fifth term would be 12 more than that, which is 67. So I wrote it like a table. You can do that if you want to be able to line up the term numbers, or you can just write it out. So it would be 19, 31, 43, 55, and 67. Both are correct. And just show that that would continue with the dot, dot, dot if you're not doing it in table format. Now we have to write an explicit formula. So remember, that takes the common difference, multiplies it by n minus 1, and adds the first term. So our A of n would be 12 times n minus 1, because the first term is the term we're starting with, plus 19. Now, if I went backwards from 19, my 0th term would be 7. So an equivalent equation would be A of n equals 7n plus 19. And if you pulled them up on your calculator, you would see that they generate exactly the same sequence. All right, let's take a look at the next one. So this time we have A of n equals 4. Oh, this one should have been A of 1. So A of 1 equals 4. It's written a little bit backwards, such that A of n equals A of n minus 1 times 2. Now, because it's times, that tells us that this is going to be a geometric sequence. All right, so now we start with the first term being 4, and we multiply by 2 repeatedly to get the next couple terms. So the second term would be 8. The third term would be 16. The fourth term would be 32. Remember, I'm just multiplying by 2 each time. And then the fifth term would be 64. Or I could write that out: 4, 8, 16, 32, 64, dot, dot, dot. So now an explicit equation in this case, again, is the common ratio being raised to the exponent times the first term. So it's A of n equals the first term, which is 4, times that common ratio, which is 2, because we're multiplying by 2 repeatedly, to the n minus 1. And again, I use n minus 1 because the first term is 4. If I wanted to rewrite this using the 0 term, it would be A of n equals, well, 4 divided by 2 is 2, so that would be the 0th term, times 2, just to the n. It's n minus 1 because we started with the fourth term, or the 4 here, which is the first term. It's n here because we started with the 0 term here. So it's important that you see that relationship, and you can realize that both of those are the same. And again, if you pull both those tables up, they would give exactly the same sequence. Okay, down here, A of n equals A of n minus 1 plus 2, starting with negative 9. So we start with negative 9 as the first term. And since it's plus, we know this is arithmetic. So we're going to add 2 each time. So the second term would be negative 7, because if I add 2 to 9, I get negative 7. The third term would be negative 5. The fourth would be negative 3. And the fifth would be negative 1, adding 2 repeatedly. And again, I could just write that as negative 9, negative 7, negative 5, negative 3, and negative 1, dot, 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 to show that it would continue. Then the explicit formula, like the one above, would be A of n equals the common difference of 2 times n minus 1 minus 9. Since I'm starting with the first term, I have n minus 1 in parentheses. Now, if I went back to negative 9 minus 2, would give me negative 11. So a equivalent equation would be a of n equals 2n minus 11. And again, if you pulled up those tables, you would have exactly the same set of values. You have the same sequence no matter which of those you use. Again, it's just important to know that if you use the first term, we put an n minus 1, and the zero term, it's just n. Okay, last one that we're going to do together on these kind. A of n equals 1 is supposed to be a of 1 equals 1, where a of n equals a of n minus 1 times 5. So since it's times 5, we know this is a geometric pattern, and we're multiplying to get each term. So our first term is 1, and our second term would be times 5, so it would be 5. Our third term, 5 times 5 is 25. Our fourth term, 25 times 5 is 125. And our fifth term, 125 times 5, I believe is 625. I'm just going to check my math real quick. Yep, I was right. It is 625. And that would continue if we wanted to go further in the table. So we could write 1, 5, 25, 125, 625, dot, 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 showing that that pattern would continue. So again, our explicit formula would be the first term times the common ratio raised to the n minus 1. So a of n equals 1 times 5 to the n minus 1. And again, I wouldn't necessarily have to write that 1 there because it's not going to change the answer, but it doesn't hurt to write it so you know what the a value is and what the b value is. And if I went backwards, a of n for the 0th term would be like doing 1 divided by 5, which is 1/5 times 5 to the n. And again, those two would give me exactly the same sequence if I were to pull them up in my calculator side by side. Okay, so again, it's important to be able to use those interchangeably and know that they are equivalent. So you guys are now going to try some similar problems on your own. Check in with me when you're done before moving on to the second half of the lesson. All right, so here now I'm giving you the explicit formula, and you're going to determine a value of the term given. So you're going to find a future term. All right, so a of n equals 32 plus n minus 1 times 22. So it's turned around here. This is the first term, and this is the common difference. It can be twisted that way. That's totally fine. So we want to find the third term. So that's going to go in for n. So we have a of 3, that denominates that we're finding the third term, equals 32 plus 3 minus 1 times 22. So that's a of 3 equals 32 plus 2 times 22. So that's the third term equals 32 plus 44. So the third term is 76. So instead of having to write out that recursive formula and keep adding 22, we could just plug the 3 into the explicit formula to find the third term. Okay, next one, a of n equals 2 times 3 to the n minus 1, and we want to find the fifth term. So we would do a of 5 equals 2 times 3 to the 5 minus 1. So a of 5 equals 2 times 3 to the 4th. So a of 5 equals 2 times 81. If you use your calculator because you don't know what 3 to the 4th is, that's totally fine. I know 3 times 3 is 9, and 3 times 3 again is 9, and 9 times 9 is 81. So 2 times 81 would be the fifth term, and it's 162. Okay, so again, instead of having to generate it with the recursive formula, I could just plug it in to my explicit formula to find any term. Okay, now 13, again, we want to plug in the 8 to the n to find the answer to the 8th term in this explicit arithmetic formula. So we have a of 8 equals negative 3 plus 8 minus 1 times 5. So a of 8 equals negative 3 plus 7 times 5. So a of 8 equals negative 3 plus 35, which makes the 8th term 32. Okay, and then lastly, we have another geometric one. I know that because of the multiplication sign here. So we want to find the 6th term. So it's a of 6 equals 3 times 2 to the 6 minus 1. So a of 6 equals 3 times 2 to the 5th. So a of 6, or the sixth term, is 3 times 2 to the 5th. Well, we know 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. And again, you could use your calculator for that if you weren't sure. And then that makes the sixth term 3 times 32, or 96. So it's just another way to use the explicit equation. You can plug in any number you want to get the equivalent value for that term. All right, so again, you are going to try some questions on your own, checking in with me as you go so I can be sure that you've got it before going on to your exit ticket and your homework.